Assalamualaikum warahmatullahi wabarakatuh. Today we are from Group 13 and we will be presenting our project name of desktop inkjet printer. So this project is focused on understanding how a desktop inkjet printer is manufactured from individual component to the final assembly. Through this project, we aim to relate theoretical manufacturing concept that we learn in class to real industrial applications. So our group consists of 4 members. So for the first member is me, Muhammad Haziq Zafran bin Muhammad Zambi, and for my group member is Muhammad Izzat Ikwan bin Muhammad Nasir, Muhammad Zafri Zakwan bin Muhammad Zali, and the last one Muhammad Shakil Daniel bin Muhammad Shahrizal. So the content we have in this slide is first we started with introduction, and the 2, 3, 4 and 5 things we will explain about the every part of process, and the last one we have a conclusion. So I will start with introduction. So the printer are essential device used in both homes and commercial environment to produce hard copy of document, schoolwork, image and simple graphics. With the increasing demand for affordable, compact and energy efficiently printers, we understand that how these products are manufactured is very important. So in this project, we focus on the manufacturing processes involved in producing a desktop inkjet printer, including material selection, machining method, and assembly technique used in real industry application. So the stage of process we started with will make about a top cover assembly, which is have 3 process. First is injection molding, CNC milling, and fastening assembly. And the second one is paper tray. And also have a injection molding, and then plastic trimming, and the last one is CNC milling. For print mechanism assembly, we have CNC lathe, laser cutting, and the press brake. For the last one of the component, we have a main housing, which is have large injection molding, CNC rotor, and the last one is flat plastic trimming.
Hi, so for part 1 is the top cover of the printer. We have a 3 process, which is the injection molding, CNC milling, and lastly is fastening assembly. For process 1, injection molding, first of all, the plastic pellets are fed into the injection molding machine. Then the pellets are heated until they melt into a liquid form. The molten plastic is then injected under pressure into a mold shape like the printer top cover. Inside the mold, the plastic spreads evenly to fill every corner and detail. After cooling, the plastic solidifies into the shape of the top cover. Finally, the mold opens and the completed top cover is ejected from the machine. So we move to the next process, which is CNC milling. First of all, the top cover workpiece is securely fixed on the CNC machine bed. The machine reads the program design detail, then a rotating cutting tool removes the material from the workpiece according to the design. So this process shapes precise contours, slots and other features, while also creating smooth surface and accurate dimensions. After the milling, the top cover is removed from the machine for further processing. Then the last process is the fastening assembly. The top cover and other parts are aligned in their proper positions. Fasteners such as screws or bolts are inserted to join the pieces together. Each fastener is tightened to securely hold the parts in place. Then this assembly method allows the section to be separated later if maintenance or repair is needed, while ensuring the parts are joined firmly without causing damage. Fastening assembly is commonly used in gadgets, motors, and applications where this assembly may be required in the future.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzat Ikwan, and today I want to present the component of the printer, which is the paper tray. Okay, first of all, the material selection. The paper tray is made from the polypropylene or PP. This material is chosen because it is lightweight and low cost, which help to reduce the overall weight and manufacturing costs of the printer. Polypropylene also has a good fatigue resistance, meaning it can withstand the repeat loading and bending during daily use. In addition, its low friction surface to allow the paper move smoothly, and it is resistant to cracking under bending. Next, component analysis. Okay, polypropylene is a thermoplastic polymer produced through chain growth polymerization of propylene. It is suitable for this component because of its combined strength with flexibility, and the lightweight and low cost nature of polypropylene make it ideal for mass production. Its good fatigue resistance ensure the durability, while the low friction surface improve paper feeding performance. It also the resistant to cracking under repeated bending, which is important since the paper tray is frequently handled. And another than that is type of machine use. There are three types of machine use. First, injection molding machine, plastic trimming machine, and CNC milling machine. Okay, the main manufacturing process is injection molding, which is allow complete shape to be produced accurately and efficiently. After that, plastic trimming machine are used after molding to remove excess material and to ensure smooth edges. And last but not least is CNC milling machine, which is used for mold fabrication or precision finishing. Okay, we move to the process of paper tray. There are three processes, which is first injection molding, plastic trimming, and CNC milling. Okay, first process is injection molding. In this process, plastic pellets are heated until they melt. The molten plastic is then injected into a mold. Inside the mold, the material fills the cavity and takes the required shape. After that, the plastic cools and hardens. Once it is solid, the mold open and finished part is removed. Injection molding is commonly used for mass production because of its offer high precision and a smooth surface finish. Next process is plastic trimming. Plastic trimming is a post-processing step to carry out after injection molding. This process removes excess plastic such as flash, runners, and gates. Trimming can be done using tools, dies, or trimming machine. This ensures the paper tray has the correct shape and dimensions. This process also improves the appearance and functionality of the final product. Plastic trimming is commonly used after injection molding, blow molding, and third morphomy. And the last process is CNC milling. CNC milling uses a rotating cutting tool to remove material from the workpiece. The process is controlled by computer software, also known as CNC. The workpiece is fixed on the machine bed while the cutting tool follows a digital CAD or CAM design. CNC milling produces precise shape, slot, and smooth surface. It can be used for various materials such as metals, plastic, and composite. To conclude that these three processes work together to ensure the paper tray is accurately shaped, well finished, and suitable for mass production.
The slide is focuses on the print mechanism, which is one of the most critical part of the printer. Firstly, CNC lathe machining is used to produce round components such as shaft and rods. The workpiece rotates while the cutting tool removes material, producing high accuracy and consistent quality. For the second one is process laser cutting is used to cut thin metal or plastic component with a high power laser beam melts or vaporize material along a precise path, resulting in clean cuts, smooth edge, and minimal material waste. The last one is press brake forming is applied to bend sheet metal into required shapes. This process creates straight, accurate bend and is commonly used for brackets and internal structure component of the frame mechanism.
So now is part 4, which I'm going to explain, which is main housing. So they can be divided to three processes, which is process 1, sheet metal fabrication, which is the frame. And the second process is the plastic exterior panels, where we uses injection molding. And for process 3 is the precision features, which we will be using the CNC machining. So for process one, which is we're gonna do a blanking, which is laser cutting to make an accurate profile slots and datum holes for assembly. And forming, which is the press brakes to create the flanks, flanges, the ribs, and the U channels for stiffness. Also fastening, which is spot welding and also riveting. So the purpose is to join the subframes and the brackets with minimal distortion, so it would stay in place just nicely. And the surface finishing is to make corrosion protection and wear resistant, so it will last longer without any wear. So for process 2, we will be molding the panels, which is for the purpose of aesthetic covers with snap fits, bosses, and also cable guides. And post processing, which is trimming, is to remove the gaze flash, ensure the edges are not sharp and also clean and won't have any harms to the users. Also, the secondary OPS, which is the CNC drilling or tapping, which is the purpose is to tight tolerance holes for screw or inserts. So note that the use jigs align to plain bottoms. And for process 3, we will be making the datum holes also, or we can call as slots, is to locate the rails, roller shafts, and also the sensor mounts. And the boss faces and standoff is to make a flat and perpendicular seat for the PCB and the model, so it can sit nicely flat. And the last one is the thread inset, which will be heat set or press fit, is to make a durable fastening for the plastics. And that's all for part 4, which is the main housing.
The last one, we have a conclusion. So for our conclusion for this project is we can analyze how a common printer is manufactured by integrating design decision, material selection, and production method with consideration. Key components were studied along with suitable materials and manufacturing process such as injection molding, sheet metal forming, precision cutting and assembly. The DNT was applied to ensure dimension accuracy and reliable assembly. The selected manufacturing approach supports large-scale production while maintaining quality and cost efficiency with optimized machine usage, reduced material waste, and efficient energy management. So overall, the project strengthened understanding of real-world manufacturing process practice and demonstrate that the purpose production plan is practically economical and aligned with modern sustainable manufacturing standard.